Usually when we think about the birth of human civilization, there is this expectation of a grand, deliberate plan.
Right.
Like we just woke up one day, stretched, and collectively decided to climb out of the Stone Age. We picture our ancestors proudly planting a flag in the ground, inventing the wheel, and, building cities because they fundamentally wanted a better, more organized life.
Well, it is a comforting narrative. I mean, it presents human history as this linear, triumphant march of progress.
Yeah.
A master plan executed by visionaries who just looked around the wilderness and decided to invent society. But that narrative completely ignores the physical reality of the planet they were actually living on.
Which is exactly what we are blowing apart today.
Yeah.
Because when you actually step into the hardcore paleoclimatology and the ancient geological records we've got in our stack of sources, that neat little timeline of deliberate progress just falls to pieces.
It really does.
The historical landscape we are looking at isn't some canvas of human ambition. It is a terrifying, chaotic environment.
It was an era defined by planetary shocks to the system. To truly understand human history, we have to stop looking at the superficial layers.
Like the kings and the battles.
Exactly. The kings, the battles, the monuments. We have to look at the real architect of the world. We have to look at water.
Welcome to the deep dive. Today, we are going to look at the literal foundation of human society. Not the philosophical foundation, but the desperate, terrifying physical reality of it.
Physical reality, yes.
We are zeroing in on the paleogeography of the Caspian Sea and the Turan Basin over the last 400,000 years. So our mission today is to explore this mind-bending premise. What if everything we call society, our engineering, our language, our cities, wasn't a carefully planned climb out of the mud, but a massive, accidental panic response to a catastrophic climate disaster that just happened to work out?
It is a massive shift in perspective.
Okay, let's unpack this, because I want to bring you, the listener, right into this ancient world. Where do we even start?
Well, we need to step way, way back to even grasp the environment these early humans were dealing with. So over the last 400,000 years, the Earth has gone through 4 major ice ages.
4 of them.
Right. And these aren't random events. They're driven by the mechanics of the solar system, specifically what we call Milankovitch cycles.
Hold on, let's break that down. Because orbital mechanics sounds like something that happens in space, not something that forces humans to invent agriculture.
That is a fair point. Think of the Earth not as a perfect sphere spinning perfectly upright, but more like a slightly off-balance top.
Okay, so it wobbles.
Exactly, it wobbles. Its axis tilts back and forth over tens of thousands of years. On top of that, the shape of its orbit around the sun isn't a perfect circle. It stretches out into an oval and then compresses back.
Oh, wow. I never realized the orbit actually changed shape.
It does. These are the Milankovitch cycles. And when these cycles align in a specific way, the northern hemisphere gets tilted just far enough away from the sun that the summer heat isn't strong enough to melt the winter snow.
So the snow just stays there, and the next winter, more snow falls on top of it.
Continually. Year after year, century after century, that snow compacts into ice, and that reflects more sunlight away from the Earth, which, cools the planet even further.
It's a massive feedback loop.
A compounding feedback loop, exactly. Eventually, you have glaciers, a mile thick covering massive portions of the globe. The peak of the last deep freeze happened roughly 20,000 years ago. We call it the last glacial maximum.
I am really trying to visualize what the world actually looked like then, because the data on human population during this last glacial maximum is almost impossible to comprehend.
The numbers are staggering.
We are talking about a global human population of just 5 million people. 5 million. That is the population of a single modern city like Sydney or Los Angeles, but scattered across the entire planet.
And the planet they were scattered across was largely a wasteland.
Right.
Because millions of cubic miles of the Earth's water were physically locked up in these massive, towering continental ice sheets. Global sea levels just plummeted.
How much lower were they?
The oceans were roughly 130 meters lower than they are today. Coastlines extended miles further out. But more importantly, without water in the oceans to evaporate and create rain, the planet became unimaginably dry.
Oh, so less ocean surface means less evaporation? That makes sense.
Exactly. Vast swaths of the Earth, fully 90% of the world's vegetation, simply died off.
But there's a glaring paradox here from the sources. During this brutal ice age, there were parts of the world that were actually doing okay. The equator, for instance, was relatively warm.
Yes, it was habitable.
Right. There were humans living in the tropics, surviving, hunting, gathering. But those humans didn't develop advanced civilizations. If you have the best weather on a freezing planet, shouldn't you be the one with the free time to invent cities and writing?
Well, you would think so, but that assumes human beings innovate out of boredom or comfort.
Which we generally don't.
No, we don't. The historian Arnold J. Toynbee proposed a fascinating mechanism to explain this, which he called the theory of challenge and response. The environment at the equator during these periods was actually too easy.
Too easy. I mean, they were still living in the Stone Age.
Yes, but there was no existential pressure forcing a radical behavioral mutation.
Hmm.
If you live in a tropical zone where you can forage and hunt year-round without the imminent threat of freezing to death or running out of drinking water, your survival strategy works.
You just coast.
Precisely. You have no incentive to change it. You remain a hunter-gatherer indefinitely because the environment isn't challenging your right to exist.
Okay, I see. It's like an evolutionary pressure cooker. If there's no lid on the pot, the water just boils away. You need the pressure to force a state change. The harsh climate was the resistance early humans needed.
That is a really good way to frame it. Toynbee argued that civilization required a very specific geographic sweet spot. It couldn't be too easy, but it also couldn't be instantly lethal.
Right, a Goldilocks zone of survival.
Exactly. Geographically, that sweet spot was a razor-thin band of land located roughly between the 35th and 40th degrees north latitude.
Map that out for everyone listening. So if you look at a globe today, that 35 to 40 degree latitude band is a horizontal slice that cuts right across the Mediterranean, through Anatolia, modern-day Turkey, straight across the Caspian Sea, and deep into the Turan Plain in Central Asia.
And during the last glacial maximum, that specific corridor was the only place where complex survival was possible, but difficult.
So if you step out of bounds.
You die. If you went north of the 40th parallel, you hit a literal impenetrable wall of glacial ice and frozen tundra. You would freeze to death. If you went south of the 35th parallel, you entered an arid, unforgiving desert, because as we established, all the global moisture was locked in the northern ice.
So these early humans are basically sandwiched in this tiny sliver of a Goldilocks zone. Death by freezing to the north, death by dehydration to the south. But I still don't see the leap. If this strip of land from Anatolia to the Caspian Sea was basically just a tough neighborhood where everyone was constantly fighting the elements, how does being trapped there automatically equal the invention of civilization? Doesn't that just mean you spend all your time shivering and looking for berries?
Well, that is a crucial distinction to make. Being in that zone didn't automatically spawn civilization.
It didn't.
No. In fact, for thousands of years, it didn't. They were highly adapted, brilliant hunter-gatherers, but they were not building cities. They were surviving in an equilibrium with their harsh environment.
Okay, so what broke the equilibrium?
What forced the leap wasn't the geography itself. It was a sudden, violent disruption to that geography. The Earth threw a catastrophic curveball that completely shattered their survival loop.
The Kavalian rise, the great cataclysm.
Yes. Around 15,000 years ago, the last glacial maximum began to break. The planet started a slow warming phase. But the warming didn't just mean a pleasant spring.
Right, all that ice has to go somewhere.
Exactly. The massive glacial ice sheets covering northern Eurasia began to melt, creating unimaginable volumes of water. This meltwater was initially held back by massive ice dams, essentially mountains of frozen water acting as temporary retaining walls.
And one of those dams failed. I've seen the geological hypotheses on this in our sources, and some models suggest it wasn't just a slow melt that broke the dam. There is physical evidence pointing to a potential meteor strike in the Arctic region.
What's fascinating here is that the trigger is still heavily debated among geologists. But whether it was a thermal collapse or a kinetic impact from a meteor, the physical result is etched into the geological record.
The dam broke.
The dam, holding back a continental ocean of glacial meltwater, completely shattered. Now consider the geography of the Caspian Sea. It is the world's largest inland closed basin. It has no outlet to the global oceans. It is essentially a giant bowl in the middle of Eurasia.
So when that northern ice dam broke, millions of tons of water had only one path of least resistance. Straight down the Eurasian landmass and directly into the Caspian Depression.
The volume and speed of this event are just staggering. The water levels in the Caspian Sea didn't just slowly creep up over centuries. They violently shot up. Geological sediment cores show the water level going from 150 meters below sea level to 50 meters above sea level.
Wait, A 200-meter rise in water.
Yes.
We need to pause and really visualize that.
Mm.
200 meters is roughly the height of a 60-story skyscraper. Imagine a wall of water that high violently rushing into a basin and filling it up.
It flooded roughly 1 million square kilometers of land in an incredibly short span of time.
Wow.
To grasp the scale, picture the entire landmass of France and Spain combined. Now imagine all of it completely submerged under a rushing, churning inland ocean.
Let's put ourselves in the shoes of an early human, or rather you, the listener, try to imagine this. You've spent generations mastering this specific slice of land near the Caspian Sea. You know the migration patterns of the animals, you know where to forage, your entire culture is built around surviving the dry, cold steppe. And then, practically overnight, you wake up to a roaring sound, and an ocean is swallowing the horizon. Your hunting grounds are gone, your shelter is gone. It is pure apocalyptic terror.
It is the absolute definition of an evolutionary shock. There is a fundamental rule in evolutionary biology: natura non facit saltus. Nature doesn't make leaps. Biological adaptation is incredibly slow.
But the physical environment just made a massive, terrifying leap.
Exactly. These humans didn't have tens of thousands of years to genetically adapt to an aquatic environment. They had to adapt behaviorally, immediately, or go extinct.
You either figure out how to float or you drown. This is when we see the first real evidence of nautical experimentation, right? Tying logs together, finding anything buoyant.
Yes. And that desperation, that sheer panic, forces a profound behavioral shift. Survival is no longer something you can do alone or in a tiny family unit. When you are fleeing a rising inland ocean, you have to organize. You have to communicate faster, cooperate closer, and pool resources.
So you're saying society started as a life raft?
The environmentalist Nick Brooks has a very compelling synthesis of this exact era in the sources. He argues that the entire concept of human civilization was an accident. It was a completely unplanned, forced adaptation to a cataclysmic climate disaster.
Now, I can already hear people listening to this and thinking, well, okay, a massive flood in Central Asia 15,000 years ago is fascinating geology, but how does that connect to us today?
It connects very deeply.
And this is where my mind was completely blown. Because this trauma was so profound, it permanently scarred the human psyche. We see it fossilized in the earliest human mythologies.
You were referring to the flood narratives.
Yes, you look at the Epic of Gilgamesh or the story of Noah's Ark or the Hindu myth of Manu. Almost every major culture has a foundational story of a deluge that destroys the world, forcing a chosen few to build a boat and save humanity.
It's universal.
For centuries, people treated these as either pure religious metaphor or evidence of a literal global ocean covering Mount Everest. But the geology points to this exact event, the Kavalian Rise. To the people living in that basin, it literally was the entire world flooding.
Because their entire known world was that basin. The trauma of the Kavalian Rise was passed down through oral tradition for thousands of years. As these surviving populations eventually migrated outward, they took the story of the apocalypse with them. It became the foundational myth of human vulnerability in the face of nature.
But the evidence isn't just in the myths. It is literally in our mouths. The words we are using right now to communicate this idea are built on the wreckage of that flood. Let's look at the linguistics of this survival, because this completely rewired how I think about language.
Language is perhaps the most durable fossil record we have of early human thought processes. It reveals exactly what our ancestors prioritized.
Right. So consider the physical mechanics of speaking. What is the easiest, most primitive sound a human vocal tract can produce? You just open your mouth and push air out from your vocal cords. A?
A simple, unconstricted open vowel. It requires zero complex tongue or lip movement.
Well, what is the easiest way to interrupt that airflow to create a distinct consonant? You don't use the back of your throat or curl your tongue. You just close your lips. B.
Right. In phonetics, that is called a bilabial stop. It is the most fundamental consonant humans produce, which is why words from mother and father globally, mama, papa, baba, they all rely on these bilabial sounds.
So you take the easiest vowel, A, and the easiest consonant, B, and you get the first complex phonetic construct, AB. When we look at ancient Turkic languages, and even looking at the ancient Sumerian language thousands of years later, what does AB or ABSU mean? It means water.
What's fascinating here is that water was the absolute center of their universe. It was the life giver, but more importantly, during the Kavalian Rise, it was the ultimate destroyer. It makes perfect sense that the most fundamental sound a human can make was assigned to the most fundamental force in their environment.
Here's where it gets really interesting, though. It doesn't stop at just naming the water. Once you have a 200-meter wall of water destroying your world, You have to fight back. You can't just run forever. Eventually, you have to stand your ground and try to redirect the water.
Which is an impossible task for a single person.
Exactly. How do humans hold back a flood without concrete or modern machinery? They dig trenches. And the linguistic root for this desperate, life-saving ditch across multiple ancient languages in that region was you are.
Let's follow the mechanics of that action. Because digging a trench to hold back a flood is a massive logistical nightmare. One person with a sharpened stick cannot dig a trench big enough to stop a rising inland sea. It requires hundreds, if not thousands, of people.
Which requires someone to tell them where to dig, someone to distribute food while they are digging, someone to enforce the work shifts.
Precisely. It requires a hierarchy. It requires shared labor. Therefore, the physical word for the ditch, you are, began to absorb the social meaning of the people required to build the ditch. You are stopped meaning just a hole in the ground and started meaning the collective organization of humans defending themselves against nature.
The ditch becomes the society.
Yes.
And we can literally trace this word through time like a breadcrumb trail. As generations pass, that primitive trench evolves. It becomes a moat. The moat surrounds a protected area. That protected area becomes a fortified settlement. And that fortified settlement becomes what we recognize as a city.
You see this root embedded in the names of the earliest major human settlements in human history. The great Sumerian city of Uruk, the ancient city of Urva in Anatolia.
And as these language families interact and spread westward, that ancient root ur hits Latin. It becomes urbanus, urban. When we talk about urban planning or an urban environment, we're unknowingly using a 15,000-year-old survival word that literally translates to people digging a ditch to stop a flood.
And the cognitive ripples go even further. Think of words like order or organization or even organ in the biological sense, parts working together for a unified whole. The etymological roots point back to this forced communal labor. Civilization wasn't born out of a desire for luxury. It was born out of the absolute terror of the Cavalian rise.
That completely flips the script on human ingenuity. We didn't invent cities because we wanted to trade pottery. We invented them to survive an apocalypse.
We did.
But the sheer cruelty of the planet is that the apocalypse didn't stay the same. Once these ancestors finally mastered the water, once they built their UR settlements and figured out how to live on the edges of this massive inland sea. Wait, no, let me rephrase that. Once they built those settlements, the climate pulled the rug out from under them again.
The Earth is not a static system. The massive influx of glacial meltwater eventually stopped, and as global temperatures began to stabilize and the climate entered the Holocene epoch, the Caspian Basin began to evaporate.
Oh, wow. So the water went away.
Slowly, yes. Over the next 15,000 years, that terrifying 50-meter above sea level peak slowly plummeted all the way back down to negative 28 meters, where it roughly sits today.
But I want to be clear, this wasn't just a gentle drying out where the beaches got a little wider. This recession of water triggered extreme local climate chaos. The geological data points to the Younger Dryas period, about 12,500 years ago, and later a localized little ice age around 6,200 BC.
The Younger Dryas is a fascinating climatic anomaly. Just as the world was warming, massive amounts of cold fresh water from melting North American glaciers flooded into the Atlantic Ocean.
So it messed up the ocean currents.
Completely. This sudden influx of cold fresh water completely disrupted the ocean currents that distribute heat around the globe. The result was a sudden, vicious return to near glacial conditions, particularly in the northern hemisphere. It brought severe, punishing winds and catastrophic drought to the Turan Plain.
So the people who had genetically and culturally adapted to an abundance of water are now watching the water literally vanish into the air. We see records of the Aral Sea, which was once a massive, thriving body of fresh water, turning into a bitter, salty puddle. And when a massive lake dries up, it leaves behind thousands of square miles of exposed salt and sand.
Which the severe winds of the Younger Dryas and subsequent dry periods picked up, creating massive, blinding dust storms.
Sounds like a nightmare.
It was. The environment was undergoing radical desertification. The fertile plains were turning into hostile, arid wastes. The rivers that fed their early settlements were shrinking to trickles.
Okay, stop right there. If I'm living in a place where the lakes are turning into salt flats, the wind is blinding me with dust, the surface temperature is hitting 40 degrees Celsius, over 100 degrees Fahrenheit, and the rivers are gone. I am packing my bags. Why on earth are you staying? Just walk until you find a river that hasn't dried up.
Many of them did exactly that, and we will get to them. But human populations are rarely monolithic. For every group that flees, there is a group that stays. The ones who stayed behind had deep generational ties to these UR settlements.
They didn't want to leave their homes.
Exactly. They'd spent thousands of years building a society based on engineering their environment. Instead of fleeing the drought, they decided to engineer their way out of it.
And their solution is genuinely one of the most staggering things I've ever read in the source material. They invented the Carrez system, also known as the Connaught system. I want to spend some serious time on this because calling it a well or an aqueduct is an insult to what they actually built.
It is arguably one of the greatest unrecognized engineering marvels of the ancient world. A Carrez is a subterranean aqueduct designed to tap into groundwater at the base of mountains and transport it across miles of hostile desert entirely underground.
Let's look at the specific example we have in the data. The Turfan Carrez, built much later by the Uyghur Turks, but relying on this ancient foundational technology. This wasn't a little ditch covered with some logs. This was a network of 5,000 kilometers of underground tunnels.
5,000 kilometers, dug entirely by human hands, using nothing but rudimentary picks, baskets, and physical endurance.
For context, 5,000 kilometers is roughly the distance from New York to London, under the desert. And these tunnels weren't just right under the surface, they dropped up to 100 meters deep into the earth. They were moving fresh water 60 kilometers away from the melting snow of the Tian Shan Mountains, the Tian Rai Mountains, all the way to their settlements. And the most mind-blowing part, they did it entirely via gravity. Zero pumps, zero electricity.
The physical mechanics of a Carrez require an astonishing grasp of geometry, hydrodynamics, and geology. Think about the problem they were trying to solve. The surface of the desert above them was baking at 40 degrees Celsius. If they simply dug a trench on the surface to move the water 60 kilometers, the heat and the dry air would have evaporated the water before it traveled a fraction of the distance.
So they put the water in a subterranean, gravity-powered, life-saving subway system to hide it from the sun?
Exactly. By keeping the water deep underground, they insulated it. It stayed cool, clean, and flowing. But the engineering required to do this is perilous. You have to calculate a highly precise, continuous angle of decline over a distance of dozens of kilometers.
What happens if the angle is wrong?
If the slope is too steep, gravity pulls the water too fast. Fast-moving water creates friction and kinetic energy, which would erode the softer of the tunnel walls, causing a collapse and burying the diggers.
Oh.
But if the slope is too shallow, the water stagnates, fails to reach the settlement, and eventually backs up and floods the system. They had to maintain a slope of perhaps 1 meter of drop for every kilometer distance.
Underground, in total darkness. Without lasers or modern surveying equipment, how is that even physically possible? How do you even start digging a 60-kilometer tunnel and know you were going the right way?
It required a highly specialized generational class of engineers. They would start at the settlement and map the route backward toward the mountains. Every 20 to 30 meters along the surface, they would dig a vertical access shaft straight down.
Like dropping a chimney down into the earth.
Precisely. Once these vertical shafts were dug, the actual tunnel diggers, called muquanas, would climb down into the pitch black. They would then dig horizontally to connect the bottoms of these vertical shafts. The vertical shafts provided the only ventilation, bringing oxygen down so the diggers didn't suffocate, and they provided a way to haul the excavated dirt up to the surface in leather buckets.
It sounds like an absolute nightmare. You are 100 meters underground, breathing dust, hoping the tunnel doesn't cave in, trying to calculate a 1-degree slope by the flickering light of an oil lamp.
It was incredibly dangerous, lethal work. Cave-ins were common, but because water was the absolute arbiter of life and death, the Muquanis were highly respected. It was a well-paid, revered profession passed down from father to son.
They were the heroes of their society.
They were the astronauts of their era, operating in a hostile alien environment to ensure the survival of their species. The system was so brilliantly conceived that thousands of years later, when the Assyrian king Sargon II encountered these underground systems during a military campaign in the 8th century BC, he was completely baffled. The records show his absolute marvel at encountering a civilization that could make water flow through the underworld.
So the people who stayed in the Turan Basin survived by becoming absolute masters of geological engineering. But what about the people who decided the salt storms and the 40-degree heat were just too much? The ones who looked at a 60-kilometer tunnel project and said, no thanks, we're leaving. Where did they go?
Well, the migrations caused by the drying of the Caspian and Aral basins are the invisible engine of modern human history. As the plains became uninhabitable, these populations fragmented. Initially, they followed the receding water, moving to the river deltas of the Sehun and Sehun rivers.
But deltas in a drying climate are volatile.
Highly volatile. They either dry up completely or they become overpopulated and disease-ridden as everyone crowds around the last remaining mud puddles. Eventually, the pressure became too great even there, so they were forced to migrate again. This time, they couldn't go north into the ice, and they couldn't go south into the deep deserts.
So where's left?
They had to go up. They moved into the cooler, wetter, but incredibly harsh mountainous regions, specifically the Altai Mountains.
The third settlements. And this is where the narrative usually stalls out in traditional history. We tend to think of mountain tribes as isolated, primitive people hiding in caves. But the data shows the exact opposite. When these highly organized, engineering-minded survivors were pushed into the Altai Mountains, they didn't regress. They triggered what can only be described as a prehistoric tech boom.
If we connect this to the bigger picture, they applied the same relentless problem-solving DNA that built the Kariz tunnels to the resources they found in the mountains. The Altai region is rich in metallic ores. Finding themselves in a harsh, rocky environment where simple wooden and stone tools were no longer sufficient, they began experimenting with fire and rock. They invented metallurgy.
Let's focus on the mechanics of that leap. You don't just accidentally invent smelting.
No, it requires controlling heat at an unprecedented scale. You have to build a furnace capable of reaching temperatures high enough to melt the chemical bonds holding the metal inside the rock. It requires forced air bellows and an understanding of oxidation.
That's intense chemistry.
It is. Once they mastered this, they didn't just make jewelry, they made tools. They forged iron and bronze.
And one of the most critical tools they forged was the heavy metal plow. If you are living on the soft, wet soil of a riverbank, you can basically just poke a hole in the mud with a stick and drop a seed in. But if you are trying to farm the hard, unforgiving, rocky soil of the steppes and mountain valleys, a wooden stick snaps. The metal plow allowed them to conquer the earth itself. They could tear open the ground and force it to yield crops.
But agriculture and metallurgy weren't even their most consequential innovations. While they were manipulating metal on Earth, they also began manipulating the local sauna. They achieved the domestication of the horse and the two-humped Bactrian camel.
Okay, domestication sounds simple to us now because we are used to cows and dogs. But taming a wild, prehistoric horse is an entirely different kinetic equation. And this is where their mastery of metallurgy intercepts with biology. They invented the steel bit and the stirrup.
The stirrup is perhaps one of the most quietly revolutionary technologies in human history.
I remember looking at this in the source text and thinking, well, it's just a leather loop for your foot. How does that change the world? But then you realize the physics of riding without one. If you jump on the back of a wild horse without a stirrup, you are just balancing on a moving barrel. If the horse changes direction, or if you try to swing a weapon or carry a heavy load, your center of gravity shifts and you fall off. You are a passenger at the mercy of the animal.
Exactly. The stirrup fundamentally altered the mechanical relationship between the human and the animal. By placing their feet in rigid loops anchored to the saddle, the rider's legs became shock absorbers. The human body and a horse's body were locked together into a single kinetic battery. Suddenly, you aren't just riding. You can stand up in the saddle while moving at 30 miles an hour.
That's a huge advantage.
Massive. You can absorb the impact of a spear thrust. You can carry massive weight without losing balance.
They basically turned horses into the first biological all-terrain vehicles. And alongside the horse, they domesticated the Bactrian camel. Now, the camel is a completely different piece of technology. It's not built for speed. It is built for endurance. It can carry massive payloads across terrain with absolutely no water, utilizing the fat stored in its two humps.
Consider the paradigm shift this represents. Before the stirrup and the domestication of these beasts of burden, humanity was completely landlocked by biology. We were slow. We could only move as far as our own two legs could carry us in a single day, carrying whatever meager supplies we could strap to our own backs. Massive geographic feature deserts, mountain ranges, vast steppes were impassable death zones. They were walls.
But with the horse and the camel, those walls vanish. The map shrinks.
Arnold Toynbee provided a brilliant conceptual framework for this in the material. He argued that we fundamentally misunderstand the geography of Eurasia. We look at the vast, dry, grassy steppes of Central Asia, and we see a wasteland, a barrier separating the quote-unquote real civilizations of Europe and China. Toynbee said we need to view the steppe not as a desert, but as an inland sea.
An inland sea of grass and dust. I really love this analogy. Can you elaborate on that? If the steppe is an ocean, then the animals are the ships, right?
Precisely. The heavy, slow-moving Bactrian camels, loaded with tons of metallurgical goods, textiles, and food, were the heavy galleons navigating the deep ocean of the dunes. The horses, fast, maneuverable, and heavily armed with stirrup-locked riders, were the swift galleys.
Just as the Mediterranean Sea didn't divide the Greeks, Romans, and Egyptians, but actually connected them through maritime trade, the vast Central Asian steppe connected the peoples of Eurasia. It wasn't a barrier, it was a prehistoric superhighway.
And this superhighway became the foundation of what we eventually called the Silk Road.
Right. And we need to completely rebrand the Silk Road. Whenever it's taught in schools, it's framed as this ancient delivery route where wealthy Romans could order fancy silk from China. But the physical trade of luxury fabrics was just a byproduct. The Silk Road was a massive, pulsing artery of information. It was how metallurgy, agricultural techniques, mathematics from the Carrese engineers, and human languages moved back and forth across the globe.
It was an engine of globalization functioning thousands of years before the modern era. And this mobility, this ability to traverse the inland sea with advanced technology, leads us to the final, most controversial realization in our deep dive. A realization that forces us to completely rewrite the traditional timeline of human civilization.
This is where we have to challenge the standard Eurocentric view of history that almost every single one of us was taught. Open any standard history textbook, and Chapter 1 always starts the same way. The cradle of civilization was Mesopotamia, specifically Sumer, nestled between the Tigris and Euphrates rivers, and Egypt along the Nile. We are taught that human brilliance spontaneously ignited in these river deltas.
But that narrative relies on a catastrophic misreading of geology. The physical reality of the Earth simply does not support that timeline. If we look at the archaeological data provided in these deep historical analyses, we see evidence of wheat agriculture occurring in Central Asia, around the Turan Basin, as early as 8000 BC. We see the complex domestication of animals happening there between 6800 and 8000 BC.
But if we look at Sumer, Egypt, and the Indus Valley, those monumental city-building civilizations only really formed and flourished roughly 5,000 to 6,000 years ago. That's a massive gap. The people in Central Asia were farming and taming horses thousands of years before the first brick was laid in Uruk or Memphis.
And the reason for that delay isn't because the people in the Middle East were slower to invent things. It is entirely a function of sea levels and water management. Remember that the melting of the glaciers was a chaotic, prolonged process. Global sea levels didn't just slowly rise to their current levels and stop. They fluctuated wildly.
Right, because of events like the massive influx of water from the North American ice lakes during the Younger Dryas.
Exactly. Because of this chaos, 8,000 or 10,000 years ago, the river deltas of the Nile, the Tigris, and the Euphrates were largely uninhabitable. They were highly unstable, malaria-infested, constantly flooding swamps. The land where civilization supposedly started literally did not have the physical stability to support permanent cities. It wasn't until roughly 5,000 to 6,000 years ago that global sea levels finally stabilized. Only then did those swampy deltas dry out enough to become the incredibly fertile floodplains we associate with ancient history.
Okay, this is the crux of the entire puzzle. If the deltas were unlivable swamps until 5,000 years ago, where did the people who suddenly built Sumer and Egypt come from? Because you don't just walk out of a swamp one Tuesday and instantly invent complex hydroengineering, cuneiform writing, ziggurats, and mathematics. That kind of knowledge requires thousands of years of trial and error.
This is where the work of Raphael Pumpelly completely bridges the gap. Pumpelly was a remarkable American geologist and explorer. In the early 1900s, long before modern dating techniques, he conducted extensive excavations at a site called Enau in Turkmenistan.
Which is right smack in the middle of that Turan region we've been discussing, right near the modern city of Ashgabat.
Yes. Pumpelly dug deep into the sediment layers of Enau and found something that shocked the archaeological establishment. He discovered evidence of a deeply ancient, highly advanced civilization. He found evidence of continuous farming, complex animal domestication, multi-room village structures, and sophisticated pottery dating back thousands of years before the rise of Sumer.
He found the beta testers.
That's a great way to put it. From these excavations, Pumpelly developed what he termed the oasis theory. He hypothesized that as the climate of Central Asia underwent that severe desertification we discussed, as the Caspian shrank and the Aral Sea turned to salties highly advanced, resilient people were forced to condense around the shrinking oases that dotted the Turan Plain.
And when those final oases dried up, when the Carrese tunnels couldn't reach deep enough to find water,
They packed up their horses and camels, and they moved. They migrated south and west. By the time they reached the Middle East, global sea levels had stabilized, and the mud of the Tigris and Euphrates had finally dried into fertile soil. Pumpelly argued, and modern geological timelines support him, that the people who built Sumer didn't invent civilization from scratch in the Delta. They brought thousands of years of accumulated hard-won knowledge with them from the drying plains of Central Asia.
They brought the blueprints. And there is physical archaeological evidence connecting these two regions, isn't there? It's not just a theory based on a convenient timeline.
The physical connections are startling. We could look at archaeological sites in Turkmenistan, such as Elton Tepe. In these ruins, archaeologists have found specific artistic motifs. For instance, highly stylized figures of the mountain goat. Now fast forward thousands of years, and we see those exact same stylized mountain goat figures appearing in early Sumerian art and pottery in Mesopotamia.
Let me stop you because that is the smoking gun. The mountain goat is native to the rocky, high-altitude ranges of Central Asia. It absolutely does not exist on the flat, marshy floodplains of the Tigris and Euphrates. If civilization started natively in Sumer, why are they drawing an animal they have never seen?
Because they brought the cultural memory of that animal with them from their ancestral homeland. Furthermore, excavations at Elton Tepe have uncovered early pictographic writing symbols. These symbols fundamentally predate the earliest known Elamite and Sumerian cuneiform scripts, yet share unmistakable structural similarities.
Which implies that the very concept of writing, the single greatest mechanism for transferring knowledge across time, might have been conceptualized in the Turan Basin before it went into mass production in Sumer.
And we shouldn't view this as simply an ancient transfer of technology that ended in antiquity. That deep, ancient reservoir of problem-solving DNA in Central Asia didn't just empty out and vanish when people migrated to Sumer. The people who remained continued to adapt. That intense intellectual culture lay dormant in the landscape, surviving the centuries, waiting for the right conditions to bloom again.
And it did. It bloomed spectacularly thousands of years later. When you look at the Islamic Golden Age, you assume all that brilliance was concentrated in Baghdad or Damascus. But the absolute titans of science and philosophy during that era came from this exact same Central Asian region.
Is not a coincidence. You look at figures like Al-Biruni, who utilized complex trigonometry and the angle of the sun against a mountain to calculate the radius of the Earth to within a fraction of modern satellite measurements. You have Ibn Sina, known in the West as Avicenna, who essentially wrote the foundational text for early modern medicine. You have Al-Farabi, the great physicist, and Omar Khayyam, who revolutionized algebra and astronomy.
All of these incredible minds came from places like Khwarazm, Bukhara, and the remnants of the Turan Basin. They weren't just sudden geniuses operating in a vacuum. They were the cultural heirs to a tradition of intense environmental problem solving. A tradition of mathematics and engineering that stretched unbroken all the way back to the guys calculating the 1-degree slope of the Kurias tunnels, and further back to the traumatized humans digging the first UR trenches to hold back the Kavalyan flood.
The DNA of innovation was literally baked into the culture of the region by the geography itself.
So what does this all mean? Let's try to synthesize all of this. If I look at the whole arc of this story, the Turan and Caspian region wasn't just a place where people lived. It was a startup incubator. It was a massive, brutal, prehistoric pressure cooker. It was the evolutionary laboratory where all the messy, difficult beta testing for humanity happened.
It really was.
The environment threw a 200-meter flood at them, so they figured out social organization and language. The environment threw a massive drought at them, so they invented gravity-powered subterranean aqueducts. The environment threw impassable mountains at them, so they mastered metallurgy and turned horses into kinetic vehicles. All the foundational research and development of the human species happened there. And then, once those survival products were perfected, the climate forced them to launch those products out into the wider world, into the newly stabilized, fertile river deltas of the Middle East, India, and eventually Europe.
The river deltas provided the perfect conditions for mass expansion. They were the mass market. But the Turan Basin, with its violent, uncompromising climate, was the laboratory that forced the inventions in the first place.
It is a complete paradigm shift. Now, if you are listening to this, the next time you pick up a book about ancient Egypt or watch a glossy documentary about the magnificent ziggurats of the Sumerians, I want you to look past the monuments. Remember the frozen, flooded, and drought-ridden ancestors shivering around the Caspian Sea? They are the ones who actually drew up the blueprints for survival. They survived the impossible flood. They dug the 5,000-kilometer tunnels in the dark.
Knowledge is always most valuable when it is understood in its proper context. We have a saying that history is written by the victors. We assume kings and generals dictated the shape of the world. But this deep dive reminds us of a much older, much harder truth. History isn't written by the victors. History is written by geography. The physical reality of the Earth, the tilt of its axis, the melting of its ice, the flow of its water dictates what humans can and must do. We merely react.
Let's take a breath and look at the absolute sheer scale of the journey we've just unpacked today. We started 20,000 years ago on a freezing, inhospitable planet where human survival hung by a thread, restricted to a tiny Goldilocks zone between the 35th and 40th latitudes.
We examine the mechanics of the Kavalian rise, watching a 200-meter wall of glacial meltwater smash into that zone, forcing humans to fundamentally alter their biology-driven behaviors, inventing boats, and literally forging the linguistic roots of the word urban out of the terror of digging trenches for their lives.
We watched them pivot from surviving an inland ocean to battling a thousands of years long drought. We saw them descend into the earth to build the Kari system, demonstrating a grasp of hydrodynamics and geometry that rivals modern engineering.
And finally, we tracked their forced migration into the Alti Mountains, where they mastered fire and metal, locked themselves onto the backs of horses with a stirrup, and rode out across the inland sea of the steppe. They carried the blueprint of civilization not as conquerors, but as highly adapted climate refugees, laying the very foundations of the ancient world.
It is the ultimate story of human resilience. It proves that we are not inherently planners, we are reactive survivors. We are at our absolute best when our backs are pressed firmly against the wall. And that leaves me with a final, highly provocative thought for you to mull over as we wrap up.
Go for it.
Look at a modern map of this region. Cities like Ashgabat, Tashkent, Samarkand. These aren't just random dots on a map where some king decided to build a palace. They are built directly on top of these ancient, desperate climate refugee settlements. Our entire concept of civilization, the very fact that we live in cities, that we organize, that we use technology to manipulate our environment, was born out of a desperate, panicked attempt to manage extreme floods and severe droughts 15,000 years ago. So look out your window at our world today. We are facing rising global sea levels. We are facing shifting weather patterns, desertification, and the depletion of our own aquifers. If everything we currently call civilization was just the emergency invention required to survive the last great climate shift, what kind of entirely new civilization are we going to be forced to invent to survive the next one?
We survived the broken, violent, flooded landscape of our geological past by fundamentally rewiring how we interact with the planet and each other. The ultimate question is whether we still possess that same capacity for radical behavioral mutation today.
Thank you for joining us on this deep dive. Keep questioning the neat and tidy history you thought you knew. Keep looking at the immense power of the geography beneath your feet, and we'll catch you next time.